Hey guys, this is Mrs. Golding. I am not in my house. It's not midnight and I'm not whispering, so it's a good week. All right, we're going to start with the product here, number 3 on your Friday paper, number 10. The product of 2 and 37 hundredths and 4 and 23 hundredths. Notice I am not dealing with the decimals yet. So I'm just going to straight up multiply. 7 times 3 is 21. 3 times 3 is 9 plus 2 is 11. 3 times 2 is 6 plus 1 is 7. I have a placeholder. Now 7 times 2 is 14. 3 times 2 is 6 plus 1 is 7. And 2 times 2 is 4. 2 placeholders. 4 times 7 is 28. I have a 2. I'm just going to use that. 4 times 3 is 12. 13, 14. Carry a 1. I'm just going to use that. 4 times 2 is 8 plus 1 is 9. We're going to add these. 1, 5, 14 plus another 7 is 21 plus 1 is 22. 10, 10. All right, so this is number 3. I have to figure out where to put my decimal. So I have a total of, counting decimal places after the whole number, 1, 2, 3, 4, 1, 2, 3, 4. My answer is 10 and 251 10,000ths. Okay, let's go to the next one. Okay, we're solving an equation here. And my Algebra 1, this will be review for you because this is what you're finishing up. And pre-algebra, this is what you're about to get into in your next chapter. Okay, it's all about inverse operations, and we need to isolate the variable, which is f. So in this one, we're going to undo this division. So f plus 4 divided by 6, we're going to multiply by 6 over 1 here, negative. Now you have a negative 6 over a negative 6, which is a 1, and the identity property says 1 times anything is itself. Okay, so we're just left with f plus 4, but what we do to one side, we must do to the other side. So I must figure out what is 28 times negative 6. 6 times 8 is 48, 12, 13, 14, 15, 16. 168, and it is a negative. Okay, because of the negative 6. I'm going to undo addition with subtraction, and what I do to one side, I must do to the other. Mrs. Golding, boop, 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 boop. Where did you get a 2? I have no idea. What should that have been? 4. Thank you very much. So let's go here. This should be minus 4, minus 4. Again, we're trying to create additive inverse. Plus 4, minus 4, those are additive inverses. If I added them, we'd get a 0. So that leaves f all by itself. 168 minus 4, we need to add those together. It's more negative, right? 8, 9, 10, 11, 12, 7, 1. And it is negative. So my answer is f equals negative 172. Right. Let's go to the next one. This one, we have, and this is how I always start my equation problems. What I do to one side, I do to the other. That helps me keep that in line. This one, we're going to combine some like terms, and so I like to use colored pencils for this. I'm going to circle 3x, and I'm going to circle negative 2x. Notice I circled the sign in front of the term. So this is a term. It's linked by multiplication. Negative 5x, those are like terms, okay? And this one, a positive 2 and a positive 2 are like terms. They're the constants in this. And really, these are all constants and they're all like terms. So I'm going to start out on the left side. I could have started on the right, it doesn't matter. 3x minus 2x is 1x, okay? Plus 4. Is equal to 6x minus 5x is 1x plus 2 plus 2 is 4. Now notice I have x plus 4 equals x plus 4. That's a true statement no matter what I put in for x. Let's put in a 1. 1 plus 4 is 5. 1 plus 4 is 5. Yep. 0. 0 plus 4 is 4. 0 plus 4 is 4. It's always going to be equal no matter what I put in for x. I could continue to work this out if I would like to. Okay, so we end up here with x is equal to x, right? And that's a true statement. So this has an infinite number of solutions. That's the sign for infinity, and you can just use that as your answer. You can also write it out infinite. If something is finite, that means it has an end. If it's infinite, that means it has no end. Infinite solutions. Okay, let's go to the next one. This is number 8. Okay, for this problem, for this equation, we have to distribute. And this is the property of distribution, where if there's a coefficient on the outside, we must multiply it by everything that's in the parentheses. So this becomes 3m plus 6, not 2, but 3 times 2 is 6, is equal to 3m plus 4. I'm going to try something here. I notice if I put in a 1 for m, 3 times 1 is 3, 3 plus 6 is 9. If I put that same 1 over here, 3 times 1 is 3, plus 4 is 7. That is not working out, is it? So you're going to see if I were to finish this up, what's going to happen? 3m plus 6 minus 4 is 2 is equal to 3m. Okay, let's subtract 3m from both sides. Can you see what's happening? I can see what's happening. What? And they don't have a clue. Who? They'll fall in love, and here's the bottom line. Our trio's down to 2. Ooh. Okay, I'll stop singing. 2 does not equal 0, right? It's a false statement. Like the last one was a true statement. X equals X. This is false. When you get a false statement, that means there's absolutely nothing that you could put in for that variable in order to make it true. So it's no solution. And the shorthand of that is this 0 with the line through it. This actually means empty set. And that just means if you tried to find a set of numbers that would make this work, you won't find any. It would be an empty set. And a set is like this, right? Those little squigglies, empty. All right. Okay, Joe Mama. All right. Number 10. Joe is a dog walker in the evenings. All right. He charges $8.50 per dog. I'm going to underline some things that are important to me in, maybe I'll put a box around it, in this word problem, okay? And he spends $9 every evening on a treat. Yesterday, he had $16.50. I'll just say that. After walking the dogs and buying the treats. How many dogs? Okay, so this is important. Here's the question. How many dogs did Joe walk yesterday? Be sure to write an equation and define the variable. Okay, we're going to first define the variable, and here's a shortcut. iLearn has lots of questions like this, and here's the trick. Look for the question. It's the one thing with the question mark. And that's what your variable is going to be equal to, and you can make your variable anything you want to. So I'm going to say, let D represent, and what does it looking for? How many dogs Joe walked yesterday? I'm going to say the number. I know that's hashtag, but it's also number. The number of dogs Joe walked. Okay, we'll keep it short and simple like that. All right, so the equation is going to use some of these other things that what we marked. Now look for something that seems like a total. Okay, so that's what I always start with. What's the end result? What's the total? And in this case, he ended up with this much money, right? But that was equal to how he walked some dogs, D, and he charged $8.50 per dog, right? Now he also bought the treats. So he spent, so that's subtracting. He spent $9. So the $8.50 per dog is what came in. That's his profit. And then spending the $9 is part of his cost of his business. All right, so we have written an equation, and we know this is an equation because it has an equal sign, it has a variable, at least one, and it has some other numbers. So I'm going to go ahead and solve this equation. Boom, boom, boom. Okay, we want to start the furthest away from the variable that we're trying to isolate. And make sure you line up your decimals here. That's why we have decimal problems on our Friday paper. 9, 10, 11, 12, 13, 14, 15, 2550, and we are left with 850D. 850 per dog. If you hear that word per, that's going to usually tell you that you're going to multiply it like that. So we're going to undo the multiplication with division. 8.50, 8.50. So we're going to have 850 over 850, which is 1 times D. The identity property says that's just D by itself. And I got to figure out 2550 or 25.5 and 8.5. Let's go ahead and let's divide. For this one, you kind of have to say to yourself, you just kind of figure out what you think. If this is 80, 8 times 3 is 24. 8 times 4 is 32. So I'm going to guess 3. 3 times 5 is 15. Carry the 1. 8 times 3 is 24 plus 1 is 25. I guessed correctly, right? So this 3 is actually the number of dogs that Joe walked. So my answer is 3. Boom. Let's go here. All right. This is division with monomials. This is a big monomial divided by another monomial, right? We could go in here if we wanted to, and we know, first of all, let me rewrite it. This did not write very well on your Friday, type very well on your Friday paper. That's the exponent. This is the exponent. Can you hear the cheerleaders? I hear them in the evening when I'm that's our Victory, K to the third. Some of these I'm learning, so I'm learning your cheers. Okay, we're going to start with 34, negative 34 divided by 2. So what's half of 34? Let's see, half of 30 is 15, half of 32 is 16, half of 34 must be 17, right? But it's a negative, so negative 17. Okay, 2, so g squared over g squared. Can you see that anything over itself is 1? But 2 minus 2 is 0, and anything to the 0 power is 1. So do I need to put that 1 here? No, because anything times 1 is itself. Now I'm on to the h's here. See, here's the h's. Remember, we subtract 3 minus 1 here. So this is h to the second power, and then k to the 5 minus 3, k to the second power. Yep, so that's my answer. Hopefully you're getting pretty good at those. If you forget, remember it's this principle here. If I have common bases and I have them raised to different powers, oops, that should have been a b. So it should be x to the a minus b, okay? Pre-algebra, you're going to want to have that memorized for your test. Identify all rational numbers from the list below. This is in number 16. All right, so if it's rational, remember it is a ratio. It can be written as a fraction. 42 over 1 is definitely a fraction, right? So that is rational. 3/4 is already a ratio. This is the same as 2 and 3/10. That's a fraction. Okay. Square root of 42, I'm going to leave for a second. What's the square root of 16? 4, because 4 times 4 is 16. 4 over 1 is a fraction, and this is 4/10. It's also a fraction. Okay, square root of 42 is between the square root of 49 and the square root of 36. It's not a perfect square, right? So we know it's somewhere between 6 and 7, and it's somewhere between, but it's going to be a decimal and it's never going to end. So this is irrational. Can't write a non-terminating decimal as a ratio or a fraction. So on the line, you should list all of these others. 42, 3/4, 2 and 3/10, square root of 16, and 4/10. Okay, hopefully the rational, irrational thing is starting to catch on. I found this one to be a little bit tricky. So I am trying to look how I did this. Yeah. Let's go ahead and do it how I've said in the past. Let's make it, let's not make it improper because these are going to get to be giant numbers. So I'm going to leave my whole numbers, and I know I need to have common denominators when I'm adding fractions. So let's go ahead with 35 here. 35. 5 times 7 is 35. 4 times 7 is 28. 7 times 5 is 35. 3 times 5 is 15. Okay, now we're going to go ahead and let's add our whole numbers. 13 plus 10 is 23. Back off by 1 is 22, right? 22, and then 28 plus 10 is 38. 39, 40, 41, 42, 43. 22 and 43 over 35. Okay, this one has a problem because this 43 is top heavy. We can't write a mixed number like that. So we're going to break this fraction down. And I wanted to do this one with you because I bet you might not remember how to do this. This is the same as 22 plus 35 35ths, right? Plus how much is left over when I take that 35 away from the 43. So just subtract. 35, 36, 37, 38, 39, 40, 41, 42, 43. That's 8. So we have 8 35ths. What's 22 plus 35 35ths? That's going to be 1, right? So 22 plus 1 is 23. And then 8 35ths. Okay, 23 and 8 35ths is my answer. If you go crazy and try to make that a improper fraction, it will work. It's just going to be really big. So these are your problems. I believe that's it for this week's Friday paper. I'm going to sign off. Love you, and I hope you have a wonderful day. Bye.